All right, we'll tackle one more weird question. All right. Can everybody try to open up QA5? Oh, by the way, I'm not saying that you guys will be getting weird question tomorrow. So all the while I'm telling you today, right, is in case tomorrow you get a weird question, in case only. So today is like a bit of like just in case. I'm worried only. For those that is on tomorrow and on May 31st. Okay, so you guys please look through this question a bit. Now 2 minutes I'll discuss already. Yeah. So after tomorrow, yeah, then paper 2 will be 2 weeks from now. Paper 2, is it 2 weeks from now? Now, for this particular one, right? So because they say that the ions are in the quality analysis notes, so very straightforward. This one, halide, sulfate, sulfide, test with barium chloride, test with the potassium permanganate. So, because the mark scheme do like that, do you recommend that I only write barium nitrate, barium sulfate? I don't recommend you guys just write barium nitrate, barium sulfate. I'll rather when you create the whole table, right? Okay. Here is where you have your reagents, the silver nitrate and ammonia. Here is where I recommend you will have barium nitrate and then potassium permanganate. Acidified potassium permanganate. Must put the whole thing. So this is what I recommend. So, but you see silver nitrate ammonia not here. Sometimes they might give marks just for, because they say testing for either halide. Sometimes they give 1 mark all for the fact that you got tried to test for halide. So always try to be thorough. I'll put in the silver nitrate ammonia. No change, let it be no change. So what if I put wrong observation here? I say that here got big fire happen. Here turn purple, blah, blah, blah. Again, it's not part of the mark scheme. They'll just ignore the whole thing. No marks is deducted. Okay, okay. So all this one very straightforward. So the anion testing very straightforward. The only reason why I like this particular essay is because for this one, 3A and the next one. Add with ammonia, light blue precipitate, then form turn dark blue solution. This one very straightforward. Okay. Solution turns lighter blue. Here, solution turns dark blue. Okay. Okay. No change. And then brown precipitate form. So what is this EDTA? Okay, I'll tell you what's EDTA. EDTA is, you're going to learn in A2, it's a ligand. It's a ligand that binds the copper ion. Again, another A2 stuff appear there. So do we really need to know this? Actually, this entire part here, right, if you still see EDTA, please don't panic. This entire thing is what we call noise. Just want to see your observation skills. Oh, yes, the whole thing is just noise. Then, sir, how do we know it's copper? We know it's copper, right? One is this one right here. There's also another way to know it's copper. Fe4 is blue in color. The minute you add aqueous ammonia, you form that pale blue precipitate, solution turns dark blue, or Fe4 is blue in color. Oh, that should give him it's copper already. Wow, then so all the EDTA, blah, 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 all this is under one category called noise. Yeah, so I want you guys to be a bit careful a bit, as in all this, right, is testing for observation skill. The EDTA is supposed to be A2. So what happens is that the ligand binds towards the copper, so less of the copper complexes, solution turns light blue. This one binds towards the copper, so that binding towards copper makes the solution turns a bit darker blue. No change because the hydroxide cannot displace the ligand. And then brown precipitate form. What happens? Later you're going to see it's because of the Fe5, right? It's going to bind towards the copper. It's going to, the Fe5 is going to bind towards the copper, thus forming that brown precipitate. Okay, so ionic equation for test 3, magnesium. Please do take note. Magnesium and copper ion reaction is metal displacement reaction. Metals displacement reaction. So the magnesium will turn brown because you form copper ion. You form copper metal. Therefore, forms copper metal and magnesium ions. So the solution turns color fade because less copper 2 ions. The ribbon turns brown because you're forming copper metal. Why got a little bit of bubble? Magnesium reacting with water. Magnesium reacting with water. So I'll recommend that you have 3 tables right here, just to be thorough. 1, 2, 3. 3 columns. That's for halide, that's for sulfate, that's for thiosulfate. Just add in the acid only. Should test in for thiosulfate. But the one very easy, you add in sulfate, add in like nitric acid, leave it for a few minutes. You should see until a pale yellow precipitate. Okay, now this one, most of it should be no problem because we did the organic chemistry experiment. If anybody will forget the organic chemistry experiment lab, go to the revision folder. There's the organic chemistry experiments, the mark scheme. Remember, we did a whole lab, the whole thing on organic chemistry. Yeah, so because I realized that you guys are not enough training for organic chemistry experiments. They can come out from time to time. So I'm just illustrating for you. So remember that they may prepare the tolerance reagent, then add potassium permanganate into hot water bath, then the 1 cm that equals sodium carbonate. This is the observation you're supposed to get. Okay, now I just want to highlight a few things. If it ever reacts with sodium carbonate, for sure is carboxylic acid. If it reacts with tolerance reagent, right, will be aldehyde or that special carboxylic acid. If it's a very acidified potassium permanganate, then it is alcohol aldehyde. It may be the special carboxylic acid, but most of the time this is a general one. But if anything can react with sodium carbonate, it is for sure carboxylic acid. So the best test for carboxylic acid, right, even if they'll put there, right, is to put in there sodium carbonate. If got any effervescence form, confirm it's carboxylic acid. So yeah, so that's the one I tell you. So let's just say you are very weird. You see that, how come silver mirror form decolorizes potassium permanganate and yet form and then reacts with sodium carbonate? If this situation happen, no anything really, confirm is carboxylic acid. Because there are 1 or 2 carboxylic acid that can get oxidized. So this is just what I want to mention to you guys.